So this is over 7.3, and I'm going to go ahead and go into certify. And I'm going to explain these problems to you. Hopefully you'll get through it. So on the first problem, we have a committee of 4 is being formed randomly from employees at a school. We have 4 administrators, 30 teachers, and 5 staff. What is the probability that all 4 members are teachers? So we have 2 different formulas that we use. One's a combination and one's a permutation. Combination, that's usually when committees are formed. Or when you're choosing a combination of, for say a pizza or something like that. Your order doesn't matter, okay? You're just choosing a group. So now in this, the way we're gonna set this up, I want to figure out what is the probability that all 4 members are teachers. So out of the 30 teachers, I will choose 4, okay? 4 of the 30 teachers will be chosen. And out of a total of 39 people, I have 39 choose 4. And so I'm going to go to my Desmos calculator, and I have to go to function right here. And down here I see combination. So I see 30, comma 4, close my parentheses, divide, and then I have combination 39, comma 4. And so I can write this answer as a fraction, 3,045 over 9,139. So we'll go back, 3,045 divided by 9,139. Okay, on our next problem, at bedtime, you read 3 books to your kids, Walker, James, and Chris. Together they have 47 books. If you decide to randomly choose 3 books, what is the probability that the 3 you choose will consist of each of their favorites? Now, each kid has their own favorite book, okay? And I'm assuming they each have different favorites. I believe that's what it says. So there's only one way you can choose 3 books where each one is the favorite for each child. I think the hardest part about these problems is probably setting them up, okay? So I have 1 out of a combination, because I'm choosing books. It doesn't matter in which order I choose. I have 47 to choose, and I'm going to choose 3. So this is the way I'm going to set this up here. And I'm going to go to Desmos. Another thing you can do is I have a little TI-30. There's a PRB button here that you can go to, and it has a combination formula on it. But it might be easier to show you with Desmos. So we have on this one, I have 47, combination 3. That's 16,215. That will be in my denominator. Right here, this is going to be my solution. So I'm going to go back to certify 1 divided by 16,215. The next one, this is a complement. The complement of an event are all the would be everything that is not in the event. So let's just say event A is baseball players who are older than 9 years or older than 10 years old. I have 11 players that are older than 10. How many players are in the complement of A? So if there are 11 that are older than 10, then the ones that are not older than 10 would be age 8, 9, and 10. So we'd have 6 and 4 and 2 would make 12. Next one is let E be the event where the sum of 2 dice is rolled, or the sum of 2 dice is greater than or equal to 11. So if you roll 2 dice, I did have a pair of dice here that I think my cat took off with him. So, you know, like the first dice you have 1 through 6, and likewise on the second. So you can, rolling 2, you can have a sum anywhere from 2 through 12. So if E is the sum of the 2 dice is greater than or equal to 11, that would be 11 or 12, then everything in the complement would be a 2. If you had a 1 on each, 3, 4, 5, 6, 7, 8, 9, and 10. Next one. This is the one with the pizzas, and we have a pizza parlor has the following list of toppings available. They're running a special, and they list all the 3 topping pizzas on individual cards. Find the probability that the winner randomly selects the card for the pizza topped with black olive sausage, and Roma tomatoes. So there's only one way to win on this. And this is another combination formula. We have we're going to have a combination. We're choosing 3 toppings. It doesn't matter in which order we choose our toppings. And I have to see how many different choices I have here. I have green pepper, onion, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I counted 15 different combinations. Okay. So we have green peppers, onions, olives, yada, yada. 15 combination 3. I'm going to go to my calculator. I can also go back and just edit this 47 to a 15. Gives me 1 over 455. So I'm going to go in 1 divided by 455. Okay, let E be the event where the sum of 2 rolled dice is less than or equal to 10. So you'd have the results 2, 3, 4, 5, 6, 7, 8, 9, and 10, because less than or equal to 10. Listed outcomes in E complement, you'd have outcomes would be 11 and 12. So find the probability of choosing a letter other than N from the 16 letters in the name Benoit, Mandelbrot. Anyway, let's count. We have 16 letters, so I know I'm going to have to divide by 16. I see if it's not an N, then I'm going to see how many N's I have and subtract that from 16. It looks like I have 1, 2 that are N's, so that would leave me with 14 that are not N's. Now, if I try to submit that, it's not going to like this because my fraction is not simplified. Okay, so I'm going to just go to my calculator. And if I type in 14 divided by 16, I can move over here on the side, and that converts to 7/8. So I'm going to convert that to 7 divided by 8. Next one, a box of jerseys for a pickup game, a box of jerseys for a pickup game of basketball contains 9 extra large, 6 large, 4 medium. If you are first to the box and you grab 2 jerseys, what is the probability that you grab 2 extra large jerseys? So let's count how many jerseys we have total. I have 19 total, and I am going to choose 4 of those jerseys. This is kind of like the problem earlier with the committee and, like how many teachers, it was, I think, the first one. If you are the first, what's the probability that you grab 2 large jerseys? There are 6 large jerseys. So you have 6, and you will choose 2 of the large out of a total of 19 jerseys, and you're choosing 2 jerseys. So this is another combination. We're going to go to my calculator. I have 6 combination, 6, choose 2, close my parentheses, divide that by combination, 19, choose 2, close my parentheses. It's easier to put your answer, type your answer in as a fraction. So that fraction is 5 out of 57. Go back to my so we got 5 out of 57. Go back to certify. All right, and there, we got it. Okay, so I hope this helps. I'm sorry I didn't do a new video earlier, but anyway, I started grade 7.3. I noticed a few people hadn't passed it, and I hope this helps you get through it. And stay warm. Bye-bye.